Welcome to Optimus DSS. This video will present you the full functionality of the online user interface. At first, the user gives his credentials and then he enters to the main page. Here, all the registered buildings of the city are listed. For each building, this dashboard displays the aggregated values of the 4 DSS indicators for the last 7 days compared to the values of the previous week. The 4 DSS indicators are the energy consumption, the CO2 emissions, the energy cost, and the produced renewable energy. The green arrow indicates an improvement on an indicator for the current week, whereas the red arrow indicates a decline. Click on the tracker link on the upper left corner to see the tracker dashboard. The results of the Optimus Tracker tool are shown here. For each DSS indicator, there are 3 values: the city's long-term target of improvement, the current progress so far, and the potential for the next year after the implementation of the selected action plans. The next page is the city dashboard. The city dashboard displays all the aggregated values of the DSS indicators for all the buildings and also provides a graphical representation for the last week. Mouse hover the graph to see the detailed values. Click on the buildings link to return to the main page. Now, click on the name of the building to proceed to the building dashboard. On this screen, the user can see the graphical representation of the DSS indicators for the selected building for a 1-week period. Below the graph, there are the aggregated values of the DSS indicators for the last week compared to the values of the previous week. On the building's navigation list, click to see the active plans for the selected building. All the building's active action plans are displayed here, along with a short description of their functionality. For each action plan, there is its daily status for the current week. The yellow boxes indicate the default unknown status. The green boxes indicate that the action plan is accepted, and the red boxes that it is declined. The user can click on each action plan's name to go to the respective page. Next is the dashboard with the building's historical and forecasted data. On this page, there is again the graph with the DSS indicators, followed by a list of all the building's data streams alongside with diagrams with their historical or forecasted values. On the top of the dashboard, a calendar is available for the user to select the days he wants to observe, and then by clicking the View button, the graphs are updated. The following page is about the weekly reports for the usage of the DSS. Here you can see all the weekly reports for the selected building for the past weeks. Information about the weekly energy consumption, the energy cost, and the number of the user's actions is being listed. All the past reports are available on PDF, while the user can edit the report of the current week. A weekly report consists of 3 basic parts. First, the provided feedback about the implementation of the DSS, problems that occurred, or other issues. After that, for each of the implemented action plans, there are comments about the usage of the action plan and the final decision about the acceptance or not of it. Finally, there is a user's evaluation for the ease of use, the acceptance and the impact of the DSS to the users of the system or the users of the buildings. The final dashboard displays a list with all the recent activity of the users of the DSS. The first action plan is a scheduling and management of the occupancy and makes suggestions about the number of occupants in each zone of the building. On each action plan's page, there is a calendar for the user to select the days he wants to observe, and then, by clicking on the View button, he can retrieve all the available data. Here, at the top of the table, the number of the occupants that is expected to be in the building for each time period is displayed. Below, there are the suggestions of the action plan for each of the different zones of the building. The cells with the green color indicate when the zone is suggested to be open, while the red indicate when to be closed. For each of the building's open zones, the suggestions for the number of occupants and the set point temperature are displayed. the user can click on a constraint cell in order to set an occupancy constraint for a specific zone and indicate that the zone has to be open on that day. This option is only available for the current or future days, and the constraints will be taken into account during the forthcoming calculations. Finally, the user can accept or decline the daily suggestions of each action plan. The next action plan is scheduling the set point temperature, proposing a suitable set point temperature for each zone of the building. The table displays the daily suggestions for the set point temperature for each zone. Click on a zone to expand and display the different suggestions of the two inference rules used, the adaptive comfort and the TCV, along with the outdoor temperature and the final rule selection. Then, click on the feedback from users to expand and see the hourly feedback that the users of the building have provided using the TCV web application. The displayed feedback uses a color code with the blue colors representing cold or cool feedback from the users and the orange-red colors representing warm or hot. The next action plan is scheduling the on-off of the heating system, which makes proposals about the ideal starting and stopping hours of the heating system. On the table displayed, there are the daily proposed starting and stopping hours of the heating system for each of the building zones. For heat scheduling, the DSS will propose a recommended set point temperature for each zone. The fourth action plan is management of the airside economizer. It makes suggestions about the usage of the outdoor air for cooling. Click on the Show Suggestions to expand and show the hourly free cooling suggestions for total, partial and minimum usage of the outdoor air. At the top of the table, there are two input parameters that can be changed by the user, the internal temperature and the internal enthalpy. Click the Update Suggestions to get the new suggestions based on the new parameters. At the top right corner, there is a field to select the method to be used based on temperature or enthalpy, and the suggestions will be updated. Next is scheduling the PV maintenance, which aims to alert the user about the need of performing maintenance on a photovoltaic plant or a relative infrastructure. The table shows for each day the total historical and the total predicted electricity production through the PV system. Click on the Show Suggestions to expand and show the hourly differences between the historical and the predicted production. The red cells indicate a big difference and an hour alarm is set. Based on the differences, the probability of a system failure is calculated and a day alert is displayed at the bottom of the table indicating the need or not of maintenance. The next action plan is scheduling the sale or consumption of the electricity produced through the PV system, which decides the amount of the produced energy that will be consumed or sold to the main grid. At the top of the table, the produced electricity and the energy demand are displayed, along with the buying and selling prices of electricity. Below, you can see the hourly proposals to buy or sell energy or try to shift the electric load. By clicking the plot icon, a graph is displayed with the hourly data for energy production, energy consumption, and prices to buy or sell energy. The user can also select his preferred optimization strategy: green to consume the energy and minimize the CO2 emissions, finance to sell the energy surplus and maximize profits, or peak to satisfy the energy demand of a building. The last action plan is scheduling the operation of heating and electricity systems towards energy cost optimization that makes proposals about the use of the heating systems, storing or selling the produced energy and load shifting. The table shows the electricity demand, the production and the electricity flow from or to the grid. The user can see hourly suggestions for removing electrical load from one hour and adding to another. Then, he can see the proposals for charging when the value is positive or discharging the batteries. Finally, there are hourly proposals for the thermal energy to be produced by each thermal system. A graphical representation of the energy flows is also available at the bottom of the page. This was Optimus DSS. Thank you for watching.